Hello guys, welcome to Unit 4, Day 1. We're going to, an introduction to inequalities. It's going to be fun. We're going to bring it on. Okay, today we're going to first learn how to graph inequalities, and let's make sure that we can read the inequalities correctly. So on the top of the screen you see it says x is less than or equal to 3. That means we're trying to somehow represent on this number line all the values on this number line that can make that true. So I know that -1, that would make it true, and -2, yeah, that's less than 3, and so is 2. And I can tell all the numbers on the number line that are really to the left of 3 are going to make that true. Where we're going to represent that is we're going to start at the number 3, and we're going to say, let me see, does 3 make it true? Is 3 included in the solution set? Nope, 3 is not. I'll make a circle on 3, and I'm going to keep it open because I'm not including 3 in my solution set. And then I'm going to draw an array. Let's see. And I'm going to include everything on the number line that is less than 3. So x is less than 3. Now let's look at the next one. It says x is less than or equal to 0. So that's going to be really everything to the left of 0. I know that, but it's also going to include 0 because my inequality is less than or equal to. So I'm going to, draw a circle on 0. Okay, come on. I'm going to draw a circle on 0. But I'm including 0. So 0 is a possible solution. So I'm going to kind of color that in. Your circle is not to be quite as big as mine. Okay, so that tells me that 0 is one solution to this inequality. But also, so is -1 and -1.5 and -0.2. All those things are included too. So I'm going to include them this way. So now my graph is showing me that everything less than 0 and 0, because 0 is now a closed circle, are values that will make this inequality true. Okay. X is greater than or equal to -1. Okay, and I just want you to be following along with me. You don't need to be drawing these yourself. Yeah, you'll have a chance to draw some later. X is greater than or equal to -1. So here we go. So I'm going to find -1. I'm going to draw a circle there, and I've got to figure out whether that's an open or closed circle. It's open. Actually, it's closed if -1 makes that true. So if I put -1 in for x, is that true? It's not true. So -1 is not included. So I'm going to keep that circle open. But everything to the right of -1 is included. Everything that's larger than -1 is included. Good. Okay. Now, x is greater than or equal to -2. Let me go over to -2. Let's draw my circle, and I've got to figure out whether that's going to be open or closed. It's closed if it actually is a solution. So if I put -2 into this inequality, yeah, it's true. -2 is greater than or equal to -2. Since it's equal, so -2 does get included. And so does everything else that is larger than -2. Remember, these your symbol kind of opens up to the larger value. So x is greater than or equal to -2. So everything that's larger than -2 is going to be included. Okay. -3 is less than or equal to x. And I can have that variable on the right side. That doesn't matter. So let's go to -3. Circle on -3. Now, -3 is less than or equal to all the values that make this true. So -3 is actually smaller than all the possible x's, or actually smaller than or equal to. So if it's equal to, I'm going to color that in. It's a closed circle. Because -3 actually does make it true because there's equality in that symbol. And I'm going to represent all of the x values that are larger than -3. You can see that this arrow is pointing to the smaller value. And so that value is going to be all the way on the left of my number line. 0 is greater than x. So let's find 0, put a circle on 0. Am I going to include 0 in my solution set? Let me see. If I put 0 in here, is that true? Is 0 bigger than 0? No, it's not bigger. So I'm going to keep that circle open. And now 0 is the bigger number. It's larger than all the values of x. So I'm going to be looking for everything that's to the left of 0. There you go. Okay. X is equal to -1. Let's see which numbers on the number line make that equation true. You got it, -1. Now, should that be open or closed? Let's see, if I put -1 in here, does that make it true? Yep, it's true. Actually, my solution to this equation is just one point on my number line. There you go, -1. X is not equal to -2, so I'm looking for all the numbers on the number line that are not equal to -2. So it's going to include -3 and -4 and -2.5 and 0 and -1.9. All those things are going to be included. The only thing that's not going to be included is this 2. The way I represent this is all those values work. All those values work. The only thing that doesn't work is -2. So I leave a hole there on my number line for -2. Okay, well now let's talk about words. So if I read the phrase, a number less than 3, that means I'm trying to find all the numbers on the number line that are less than 3. So I can write that as an inequality by showing x, by writing x is less than 3. So let's go ahead and graph that. I'm going to draw a circle there. And let's see, is 3 included? No, 3 is not included, so I'm going to keep that open. And let's draw my line. All the values are less than 3. Okay. 3 is going to be larger than every value that's graphed, because you can see that in this inequality, it opens up to 3. Okay, 3 is the larger value. Okay, now I'm looking for a whole number less than 3. So what is a whole number? Remember, a whole number is really a positive integer or 0. So let me see. I'm going to look at 3. Does 3 work? No, 3 does not work. Who does work? Let's see. 2 works. And 1 works. And 0 works. So does -1 work? Nope, -1 is not a whole number. Okay, whole numbers are either 0 or positive. So I think I'm just going to erase this because he doesn't work. And there you go. Sometimes we use graphs like this when we're talking about things that we can actually count, like the number of people or the number of buildings or the number of cities, things that are numeric that you can't have half of. Okay. All right. If I tell you that you can have no more than 3 pets, you just sign an apartment lease, you can have no more than 3 pets. In order to interpret what that means, we've got to look at the words no more than. Now, sometimes you'll think of the word more and think, oh, that must mean greater than. Okay. But I want you to not do that. I want you to actually think about what the words mean. So, can I have 3 pets? Yeah, I can have 3 pets. Can I have 4 pets? No, I can't have 4 pets. Can I have 2 pets? Yeah, 2 is no more than 3. Can I have 1? Mm-hmm. Can I have 0? Yeah, I can have 0. Can I have -1 pets? No, that doesn't make any sense. Okay. So the way I'm going to represent this in math is the value of x has to be less than or equal to 3. So whenever you see no more than, that's really less than or equal to, because it includes 3, it includes that boundary. And in this case, since we're talking about animals, x has to be a whole number. Okay. So I can just specify that right there. X is a whole number. Let's look at the next one. It says a troop must have at least 5 members, at least. So when you think of the words at least, I want you to really think about what they mean. Can I have 4? No. Can I have 5? Is 5 included? Yeah, 5's included. Can I have 6? Yeah. And so on, I can have the rest. So if I were to write this mathematically, I would say the values of x are greater than or equal to 5. And I would say that x is a whole number. Now that's just because we're talking about things that you can count, like people. But if we were talking about things that you couldn't count, that you could have like 5.5 of or 7.2 of, then you could just represent it by just drawing a line. Okay, that would be fine too. Okay. You must read for at least 1 hour, at least. So visually on my graph, I'm going to be focusing on 1. Let's see, is 1 going to be included? Yeah, 1's included. I can read for 1.2 hours or 1.5 hours. I can read for all of that, so I'm going to make a line there. And this represents at least 1 hour. And the way I would write that mathematically is x is greater than or equal to 1. Okay? At least means greater than or equal to. And I know that's kind of backwards in your head because you think of least and you think of less than. But I want you to really think about the meaning of what the word at least means. Okay. X is at most 1. That means the highest value of x I can ever possibly have is what? 1. So is 1 included? Yeah, 1 is included. So which side of the number line am I going to be plotting? Well, 2 won't work. Will 0 work? Yeah, 0 will work. Will -2 work? Yeah, -2 is at most 1. Sure. So it looks like I'm going to be shading the left side of this number line. And there you go. At most means less than or equal to. At most means less than or equal to. It's vocabulary that you're going to just have to be careful and think through. Okay. Your turn. On the flip sheet that I provided for you, I want you to graph numbers 1 through 6. And go ahead and pause me so you have an opportunity to look at it. All right. Now you're going to graph 7 through 10. Just read what the sentence says and please graph the idea that I'm trying to represent. So for example, you should eat at least 5 servings of vegetables a day. So please show me what that looks like. What does at least 5 servings mean? Okay, when you're just going to pause me. Now for numbers 12 through 14, just go ahead and don't make your own number line, but just change the numbers under your number line to make it something that actually fits these problems. Okay, so for number 12, I want you to graph the ages of people who are not admitted to R-rated movies. For number 13, I want you to graph the valid temperatures that you can have to be able to come to school. Okay? You can't come if it's 99 or above. Sorry, you're sick. And go ahead for number 14, graph the grade that you need in order to be able to pass algebra, although I want it to be high, much bigger. Cool. I'll see you in class.